Huh. Good afternoon, all. Am I audible and visible? Hello, participants. Yeah, okay. So, again, I welcome you all on the last day of FDP Smart Health AI Solution for the Modern Healthcare Systems, organized by Vidush Institute of Technology, a constituent institute of Kadi Sarva Vishwavidyalaya. Our 6 days first session that will be conducted by Chetan Hirapara sir. I am briefing about him. He is a lead senior data scientist at Teradata, based in Ahmedabad, India. He has over a decade of experience spanning the software development, data science, and AI ML ops. Some of his specializations include generative AI, leading AI research and development projects, and delivering through the leadership through blogs and speaking engagements. He holds a bachelor degree in information and technology from Gujarat Technological University. So I welcome Chetan Hirapara sir to deliver the session.
Hello, I hope I'm audible.
Yes, sir, you are audible.
Okay, good afternoon, everyone. And
Good afternoon, sir.
this is going to be exciting session. I'm definitely sure that you will have some good hands-on at the end of this session. And since like everyone was talking about the machine learning and deep learning throughout the sessions, right? So you might need some kind of refreshments or get your hands dirty by doing real hands-on. So that I have planned. So first I will explain about a little bit on this machine learning, deep learning, different algorithms, then how that can be useful in this medical field especially. And then I have one notebook, and I would expect everyone would have a Kaggle account and a Google Drive account. So I will share one Google Drive link where I have a notebook as well as data. So requesting everyone, if you don't have, then please create one Google Drive account and make sure you have Google Drive and Kaggle ready to use in your laptop. Okay. And as Madam has already explained about me, I'm lead data scientist at Teradata, where my day-to-day job is regarding pre-sales data science job where we have to talk with customers and fulfill their POCs and new latest technologies that is going on in the market layer. For example, agentic AI system, MCPs. So all these cutting edge technologies that we are doing on our day-to-day life job. Without wasting your time, shall we start, madam?
Yes, sir.
Okay, let me share my screen.
Screen is
Okay,
visible, sir.
thank you. Is this PPT visible?
Yes,
Presentation?
sir. Yes.
Okay, so today's topic that was given to me is decision predictions, disease predictions using machine learning. Okay, and since like what I have observed, I am working in this generative AI field since last 3 years, and I have observed that uh, most of the companies still using machine learning for model predictions like heartbeat dialysis detections or COVID detections or uh, any kind of other cancer detections, time series based, right? So still machine learning is still applicable. Okay, so it is not something that machine learning is replaced totally by generative AI. And I'm also like very well experienced on this machine learning, and I would definitely say recommend that if you are doing some kind of predictions, then rather going to this fancy technology, you should try with the machine learning. Just because of that, there are some good advantage. Machine learning will give you the explainability rather than the black box, right? If someone is saying that this person has a diabetes, then in the machine learning you will get that explainability why that person has diabetes, right? So that is very important, in especially this kind of critical domain where someone's life can be written, right? In this session, I will explain you about some key concepts, some key technologies, algorithms. that most of the data scientists use in their day-to-day life while they start their journey in the machine learning. Okay, as I said about myself, I am LinkedIn top voice and I'm also AWS community builder in machine learning since last 3 years. And I had delivered about 20 plus projects in the generative AI since last 3 years. That includes some kind of advanced chatbots, some kind of automations, complex workflows. Then I'm also contributing to open source community, especially in the GenAI projects, and a technical speaker across AWS, GCP, open source community. And you might have seen many of my blog posts on the LinkedIn and all. So I'm very much contributing to the LinkedIn and YouTube as well. Okay, so next is sorry, there are some text are overlapping just because of the different different tools. Okay, so our introduction to disease predictions using the machine learning. So how we are predicting the disease, right? So very basic things is that we should have a good data, right? Without a good data, it is a garbage in and garbage out. And the very reality of the, especially in this kind of medical field, is that there is a very few real data that you will find. Okay, just because no one, no company, no hospitals, no country will share that real human data on the medical field. So that is one of the key factors when we are starting any machine learning model development. Before that, we should make sure that we have good historical data to identify the patterns to predict the outcomes based on the new input data. In healthcare, ML models are built using large data sets like patient records, genetic, medical images like X-ray, CT scan, MRI, right? So based on these different input data sources, machine learning models or deep learning models are try to identify whether that person has a fracture or not, whether that person has a cancer or not. But everything is like actual. Nothing is like in the black box. So that is the very really good beauty of the machine learning rather than the generative AI. So how this process start? And like let's say type of disease predictions and what are the different models. So ML models are tailored to specific type of disease. Like one type of disease is a chronic disease where conditions like heart disease, diabetes, or cancers are often require longitudinal data and are predicted using structured data sets from patient records. So these chronic diseases are very critical. So, okay. Then infectious disease. So infectious disease like the COVID-19, then such kind of influenza or some kind of cough, cold and fever. So such kind of infectious disease. So that can be also detect from the different mechanism. Next one is the mental health disorder. So that is very critical and it is very hard to detect just because of it mental one. It is a very critical just because there is a neuroscience and lot many other things is applicable and you really have good number of data and good quality data, then only it can be possible. Then rare disease. So rare disease, there are lot many data publications. Even a few months back, I come to know that people are trying to create a knowledge graph using all these rare disease like dementia disease, right? So they are trying to extract all the publications data from the internet, from PubMed, and they are trying to build some kind of knowledge graph. So these are kind of things that people are already trying to build some kind of knowledge base, to build some kind of good quality data. So people can do some analysis on top of that. If we talk about the machine learning processes, then how machine learning process will start, right? So first we have to collect the clinical data. Then we have to do data pre-processing. So pre-processing is the very critical steps in any machine learning project. Since like in our day-to-day job as a data scientist, we are spending almost 70 to 80% of our time in this data cleaning process. Just because data cleaning is critical. Once you have good data, then definitely your model will generate a good outcomes. So that's why it is critical. Second thing is that before jumping to different machine learning models and all, right? If you have good data, good quality data, where you have already detected all the uh, biased, whether data is imbalanced or not, missing value analysis, outlier analysis, right? Then you will have a good understanding about your data, and according to that, you should apply the machine learning algorithm. It's not something that you randomly select or everyone is talking about executes and you should use it, right? So that's why data pre-processing will really help you to identify patterns. It will really help you to check your statistics on your data, what type of data you have, how you should process it, whether it has a skew data, whether it has a imbalanced data, then what are the different steps that you can apply on the imbalanced data. So that's why data pre-processing is very important. The next one is the feature selections. Many times we have seen that in the Kaggle data sets, people have generally used 10, 20, 50 features, but in the real world, there are thousands of features. And also records are very low. Many times we've seen that there are 1,000 features and records are only 100. So this is a critical case, like whether you should eliminate all the features and only keep top 10, top 20 features, whether you should generate a new features, you should extract the new features. Feature extractions, that means like if you have a date of birth, but this specific date is not that much of important for you, then you can derive like a month or year or age, such kind of features. So this is a feature extraction. So this feature extraction and feature selections will help you to make your model consistent. Many times what happens, like if you have multiple features and very less number of records, your model will be biased or your model will be imbalanced. Imbalance, that means that it behavior will be inconsistent. Sometimes it will say that that person has a diabetes, and sometimes it will say that that person doesn't have diabetes. So this randomness that we have to tackle, this variance we have to tackle, and feature selections and feature restrictions can help you in that kind of things. Cluster based over sample method. So what happened that when we collecting some kind of data in the as especially medical domain, so we can create different cluster based kind of things. Like if you think about the COVID scenario, right? It is not something that in particular one geography there are similar kind of patients, and in another geography there will be different kind of patients, right? So if you do some kind of clustering, then take some samples, right? Even if you remember in India, in especially Ahmedabad, municipality was doing some kind of samplings from one area, right? And based on that, they are identifying some kind of analysis, and they are declaring some final conclusion. So sampling, that means if you have 1,000 of people in one area, right? So you take 50 people randomly and then do a blood samples and try to check different elements on the bloods and all that. So that is the sampling. Especially this sampling things is very important, just because it is impractical to take everyone's blood samples and do this analysis. So that's why you have to select perfect sample. There are also sampling methods, random samplings and density-based samplings. Then clustering. Once you define the samples, then you do clusterings, and based on the clustering, it will really help you to identify, or it will really help you to go more detail in this particular machine learning analysis. There are two type of things, like one is classification and one is regression, right? So classification is majorly like when you have binary outcomes or where you have a multi-class outcomes like low, medium, high, right? So if you want to detect a COVID severity, then it could be binary, positive or negative, or it could be severity based, like high, medium, or low. So that is a classification. Now we will talk more about like what are the different algorithms for this. So machine learning algorithms for decision predictions, where you have classification kind of problem. So first one is the logistic regression. Logistic regression is works on the sequence functions, and it has two outputs, either 0 and 1. Okay. It is not building any kind of probabilities or anything. So you at the end you will have one output that is either 0 or 1, right? So what it will do internally, so it calculates the probability of the target variable based on the set of input features. The input features could be age, blood pressure, cholesterols. Then there are many other things. Okay, or your height, uh, how many diseases you have, how many dental digits you have, and all these are your features and your target variables. Let's say there is a diabetes or not. Okay, so it will only give you two outcomes, either 0 or 1, that person is diabetes or that the person doesn't have diabetes. So internally it will apply the sigmoid functions and calculate all the features importance. It will calculate all the features contributions, and based on that it will identify the final outcome. Now when to use this is predictions, logistic regression, this is prediction. So widely used in predicting the diseases like heart disease, diabetes, where the outcome is binary. It's simple, interpretable, and efficient for datasets where relationship between input features and output features are mostly linear. So I will talk about this linearity. So linearity, many times we have seen that in the real world data, hardly you will get that linearity, right? So linearity means that let's say in x-axis there is a height and in y-axis there is a weight. Okay, so suppose you say that that person's height is 160 centimeters, then weight should be, let's say, 60 kg, and that if that height is increased, the weight is increased. So this is kind of linearity. This is hardly we can see in the real world example, just because there are a lot many noise in the data sets. So when your assumption is that your data is linear, there is no multicollinearity between different features. Like features, that means like, let's say, age and cholesterol. Okay, suppose these two features are collinear. One is get increased, another one is get increased by some points. So if any kind of such linearities that you found in your input features, in such cases, you should not use the logistic regression. So this is like pictorial explanation about the logistic regression. So you can see here 0 and 1, and this S shape, it's called a sigmoid function. So this is the threshold value. You can move this threshold value up and down, but by default, 0 0.5 is by default threshold value. So when we calculate the probability of that person's diabetes, yes or no, right? So in that case, we are getting, let's say, output is equal to 0.8. That is greater than your threshold. Then your uh, this logistic regression function will say, yes, that person has a diabetes. If it is going to be below, then it will say that no, that person doesn't have diabetes. So this threshold, if you move this threshold to up, okay, so what will happen that you will get less positive cases and more negative cases. So whenever you decide like what kind of disease you are predicting, what kind of algorithm you are implementing, what is the critical situations, based on that you should decide this threshold whether it should be up or down. Next one is the random forest. So one more point I would like to explain in the logistic regression is that logistic regression, there is, you have good explainability. Suppose some person has a diabetes, and if he comes to your lab and he said that, hey, can you tell me why your machine learning model is saying that I have diabetes? In that case, you should have an explainability. Like, just because logistic regression is working on the contributions factor, so each contributions, that means each input variable is contributing something to your final outcome. Okay, so you will have the contributions factors, like if age is contributing factors, if cholesterol is the contributing factors. So based on that, you can say that, see, you have a high cholesterol, and that this is the main reason that this machine learning model is giving you that you have diabetes. So logistic regression is good when your explainability, you require the explainability and the first priority. In that case, you should go with the logistic regression. The next one is the random forest. When you will get little bit complex one. Random forest is like, you can consider it is a set of decision trees, and decision trees are a set of features. So let's say you have 100 features, and there are 10 such trees, decision trees. Now each decision trees will use some sample of features to predict the outcome. So it is very good algorithm when you have imbalanced data sets, or where your data has some kind of noise, right? So in such cases, you should use this. Also, it can be perfect fit for nonlinear data as well, when there is a noises exist, right? Or even if it is a missing value is there in your data set, you don't need to worry about that. So random forest will take care of all of these things. So random forest is ensemble learning methods that construct multiple decision trees during training period. Each tree votes for the final predictions. So these 10 trees that we were discussing, so all these 10 trees will take some vote. Right? So like let's say 7 trees are saying that that person has a diabetes, and one say that it is a zero, right? So we will take most votes, and the final decisions will be based on the most vote. So that's why it takes the variance, it takes the a good number of different features, and that's why it is a more robust than the logistic regression. So this is a pictorial example. So let's say you have a fruit basket, and a person is saying that fruit color is red, and it tests the sweet, and its shape is almost a round shape, right? So these are my input things. These are my input features. Now, based on this, these are decision tree 1, tree 2, and tree 3. All these tree will be different, just because they are going to use different set of features when this tree is getting built. Now each node will check the entropy. So entropy is basically a threshold mechanisms, or it is one kind of calculations where it is checking that whether this entropy is greater than this, then it should go in this way or this way. So every time it has to take one decision whether it should go to left or right, and it is a binary decision tree. So you can see that every nodes has a two more nodes, and at the end it is a leaf node, right? So you can see that this in the output, the shape that I explained, that it is a almost round shape. It's with, and it has a red color. So you can say that based on the fruit basket is identified that tree one is saying it is apple, tree two is saying it is apple, and tree, let's say N, or tree three is saying it is a banana, right? So what will happen, that majority of votes will taken considerations and final vote will be taken count. So that is a apple. If it is a regression problem, okay, so there are two type of problem in the machine learning classification, where you have a 0 and 1 kind of probability. In the regression, where you are predicting, like let's say you are predicting probability between 0 and 1, or what are the probability of that person has a COVID, or what are the probability that person has a diabetes, right? So in such cases, what will happen, random forest regression tree, it will take regression methods, it will apply regression, and it will take a mean of all of these. Right now, you can say there is only single words, right, from all. But in the case of regression, it will take mean of tree one, mean of tree two, mean of tree n, and then all the means will get merged, and then it will get the final mean output. So in the random forest regression, it will work in this way. Next one is the support vector machine. It is more on the mathematical side of algorithm, where it trying to identify separations of two set of classes. One is non-diabetic and one is diabetic. Okay, and it is trying to identify that one perfect plan that divide these two set of classes. Uh, it requires a good number of records. It requires a good computations power, just because it is machine learning with mathematical algorithm. So SVM supports classification algorithm that works by finding the hyperplane that best separates data points for different classes. It can perform both linear and nonlinear classification using technique called kernel tree. So this kernel tree, there is a SB, and there are lot many other kernel, around 10 kernel tricks are there. So that is kernel tricks, that is a mathematical formula basically. So if you change the kernel tricks, your outcomes will be the change. Okay. To transform the data into higher dimensions where it is easier to separate. Next one is the disease predictions, right? So in the frequently applied to cancer classification problems, like detecting the breast cancers from biopsy data and genetic disease predictions, SVM is effective for data sets with the clear margin of separations between classes, and it is known for its ability to handle high dimensional data like gene expressions profiles. So if you have high dimensional data, in that case, you should also use this one. What will happen if you use the random forest high dimensional problem, right? So it will divide the data sets into more variants, and it might get overfitting of that model. So when you have a very high dimensional data, in that case, I would recommend to use SVM. Now, the pictorial representation of SVM. So you can consider that there is two dimensions right now, X and Y. And in the picture one, the top picture where it is saying that it is a good margin, all sector vectors have the same distance with the maximum margin hyperplane. So this black color line, that is a hyperplane. Now what it is doing exactly? So you can see that there are some green dots and there are red dots. So it is basically dividing these two type of classes into perfectly same distance. So what it is doing, it is just trying to cut these two set of classes in perfectly shaped manner with equal distance from the edge node. So this is called edge node. So this is a good margin, and this is why this is called good margin, just because it is has the same distance from these three nodes and these two nodes. Now, when someone will give you the new data points, what it will do, that it will first convert the data points into these two dimensions, and then it will try to check that whether that data points is coming to this right side or the data points is coming to red side. So based on that, it will say that, hey, this data points is coming to right side, and that person has or not has water. So I can see right now that person is coming to green class. This person is coming to red class. In the bad margin, very close to either class, it could be one class or other class, support vectors, or class plus one support vectors, right? So this is class plus one and this class minus one. Okay, so you can just consider it as two classes. So why it is called bed? Just because of that, this line that I was trying to draw, it is touching to some of the points, and it is far from the red of the points, and that's why it is a bad margin. So when you train a machine learning model, SVM is trying to draw this line that could make a perfect separations between red class and the green class. Next one is the k nearest neighbors. So this is very simple algorithm. Basically, it is non-parametric algorithm, and even it doesn't need a training. Okay, so it works by finding the k closest data points in the training data set to make a predictions about the new data points. It assign a class based on the majority levels among the nearest neighbors. And when to use this KNN algorithm? When you have a low number of data sets, right? In that case, I would suggest to use KNN. KNN is useful for disease classes such as diagnosis of the heart disease based on the input features like glucose level and age. It's intuitive and doesn't make any assumptions about the underlying data distribution. That is again a negative point. So most of the algorithms make some assumptions, right? If you remember, I was talking about the assumptions of multicollinearity, like one variable should not be depends on the another, right? So such kind of assumptions. So in the KNN, there are no assumptions. So basically, this is a negative points. So whenever you use this KNN, you should make sure that it is perfectly what are the decisions you take. It should be perfectly aligned to your assumption. It should be perfectly aligned to whether you want to use or not. Yes, someone has raised a hand. Shall I move ahead or in question? Dr. Akhil, I can see your hands. Okay, let's move. So KNN, so it is very simple algorithm. What will happen that there is, you can see there is one gray points, and it will try to check the calculations between other points. So start by calculating the distance between the gray points and all the other points. Okay. Now calculations could be different calculations like Manhattan distance, cosine, all other calculations distance, and here it will do this one-to-one calculations between one points to other points. Then find the neighbors. So if you see that this gray points has a two green color neighbors, light green, one is green and one is near to red. Okay. And based on that, it will check which has the most words. So these two, light green has a two words, other are the one. So my final outcomes will set to this light green color. So that's, it is a simple and it is non parametric algorithm. Next one is the CNN. So CNN is a convolution neural network. It is a deep learning technique where it will, when you give one X-ray image, so it will divide that X-ray image into some kind of chunks or some kind of blocks. Then each blocks will identify from pixel by pixel by pooling layers. Then it will apply the dropout layers, again pooling layers, again dropout layers. So basically, if you have 128 cross 128 image, so it will divide that into 3 cross 3 or 4 cross 4 blocks. It will just like you can say that it is just scan the entire image, right? And based on that, it will identify all these blocks, all these dots, all these pixels in your image. And at the end, it will give you, let's say it is an X-ray, right? Then it will give you whether that person has a fracture or not. So here, one pictorial representative of the same. So let's say you are giving one input image of giraffe. So this yellow color box is a kernel. Then it will apply the convolution layers on top of that. ReLU is activation function. Then again the next layer, then again the next layer. In between, you can use max layer. Then you can also use dropout layers. So dropout layers will just deactivate some of the neurons. At the end, it will. So these are the feature extraction. Basically, feature extraction. This is similar like what we did in the machine learning. In the machine learning, there are numerical features, and here it is a pixel-based features. Then at the flatten layer, after the flatten layer, the classifications will start happening. So let's say there initially there is a 28 nodes or 24 nodes, then these nodes will get reduced. And let's say you have final outcome, it is a multi-class outcome. So you should use the softmax activation function. If it is a binary, then you should use the sigma activation function. So from the multi-class softmax activation function, it is a probabilistic distribution. So sum of all these probabilities would be one. And at the end, it is saying that this picture is a zebra just because it identified that the probability is 0 0.7. Data sources in the decision prediction. So till that we discuss about different machine learning algorithm. Now we are going to discuss like how we can do data collections, then the data extractions, then feature selections, and other things. One is like EHR data. So it is majorly used electronic health data records that contains patient information such as age, medical history, lab results, and all the treatments that that person or patient is taken. Genomics data used for precision medicine, identifying gene and variants that may lead to specific disease. Okay, so genetical disease identification, it is also very important, and it has a more complex data sets than the other one. Medical imaging where X-rays, CT scan, MRIs that are also get analyzed from this CNN kind of deep learning based algorithm. Wearable device that Kamal madam has already explained in one of the session, where you have IoT based sensors data. It could be Ring, it could be Apple Watch, right? So it is continuously checking your heart rate. It is continuously checking your SpO2 sleeping data. And based on that, it is generating some data. So these all are the different kind of input data sources for machine learning. Last is the laboratory data where it is a normal like what we have like blood, glucose, cholesterol, all these different kind of data sets. Then very first features is very first step was the data sources. Now we starting with the data cleaning. So data cleaning, how what are the different steps in the data cleaning? One is the in the healthcare data set missing values are common. Just because of that, some like let's say you are doing some blood test, okay, RBC or some blood test, and some machine is failing in particular X parameter. There is obviously it will be missing value, right? So in healthcare, there is a high chances that you will get a good number of missing values data. So missing value handle is also critical. Okay, just because in especially in the medical terms, you should not use any random or mean-median mode imputations, right? Just because it may fail in some of the cases. Okay, so you have to do clustering based on the age group, and then after you should check what is the mean value of that clusters. So first problem is the missing value analysis and how to fill that missing value data. So via mean, median, mode imputations, and one another algorithmic tracking is the KNN, right? So what you can do that you can identify k nearest neighbors persons to that missing patients data, and then you check what are the values of that k nearest patients, and you can impute those missing value. That is one algorithmic technique. Incorrect data such as negative values for age or impossible blood pressure reading need to be identified. Many times we have seen that uh, in this data analysis, many times it could be that age of that person is let's say 100, or the blood pressure is like very high, or sometimes blood pressure meter is not working perfectly and it is giving you negative value or near to zero value, right? So such kind of things, if as a human you are checking this data, then definitely it will trigger your mind that this is some kind of imperfect data, or this is some kind of missing data that needs to be cleaned. But as a machine, when you apply this kind of things, you have to apply some kind of algorithm that can detect like outliers. So let's say all the persons has a blood pressures like 80 to 120 range, right? And someone is getting let's say only 10, right? So this kind of things are outliers. It might be possible that it is a correct one, or it might be possible that it is incorrect due to a machine error. So that kind of things that we be applying this cleaning or data exploration things, we should make sure it is perfectly handled. Feature selections. Not all the variables in the medical data sets contribute significantly to the disease prediction. Selecting the most relevant features, let's say age, blood pressure, cholesterol level, can reduce the computational cost and improve the model's accuracy. Okay, so nowadays computational costs are highly people are looking, but the most of the important thing is that there is accuracy, there is a precision recall that should be taken care. So again, like coming to the feature selection. So if you have 1,000 features, then definitely it is meaning that it is not all the 1,000 features are important. There are different technique. One is recursion feature elimination. So recursion features elimination, so it will take all the 1,000 features and gradually it will eliminate one features and it will check what is the effect of the outcome, what is the effect on the features. Let's say I have 1,000 features and I started eliminating 50 features, there's no effect on my outcome variables, right? So again, I should continue. Like let's say I'm removing the features number 901 and there is a huge impact on my outcome. So I will not remove that features, I will keep it. So this is called recursive elimination step. And one is the lasso regression. So lasso regression is like when you have 1,000 features and output variables has some kind of probability, right? So you should consider that out of all this 1,000, let's say there are 100 features, those are contributing near to zero, right? So there is L1 and L2, two kind of lessons. So you can apply that wherever there is a near to zero, you can apply the L1. So it will make that perfect zero rather than keeping that variables into your uh, uh, forward processing of the train. So these are the different feature selections taking. Apart from that, there is a correlations technique. If your all the features are numerical, then you should check what are the correlations between age and blood pressure, right? So based on that, you can identify that if there is highly correlated features, then no need to keep both the features. You can remove one features. Like let's say one a feature is date of birth, and there is also features about like yeah, date year, date month, age, right? So all these other features can be derived from your date of birth. So you should remove that features. Normalization standardizations, it is very important, especially in such of the cases where your values is varies. Like in the blood pressure value could be 80 to 100, and in the glucose uh, in the glucose this values it would be 0 to 0.12 or something, right? So these are the different scale value, but machine learning model will not understand that these are the different scale, right? So before passing this to the training of the machine learning model, you should do either normalization or standardization. So normalization, what it will do, it will scaling, it will convert all this data to range between 0 and 1. And the standardization, it will divide all these data points into three standard deviations from 0, 1, and 2. So standard deviations, it will standardize your data. So what it will do that it will do subsections of the standard mean value and divide by that mean value. So all your data will be divided into three standard norm deviations rather than in the uniform, yeah, random behavior or your uniform distributions. Next one is the data augmentations. This is very important in the image cases, right? Let's say you have X-ray images and there are very less number of images you have in your data set. Then you can do data augmentation. So basically, you want to generate from 100 images to 1000 images. So that is data augmentations. What different kind of techniques like flipping, zooming, rotating, noise addition. So these are the different things that you can add to your images. So you will have a diverse set of data sets, imbalanced data sets, that is very critical to handle that. Just because of that, if your data set is imbalanced, let's say you have 1000 data points and the data points are predicting diabetes true or false. Out of this 1000, let's say 90% of the people, 90% of the sample doesn't have diabetes. And when you train a machine learning model, your model will always say that, hey, this person doesn't have diabetes. And you will say, that, hey, my model is doing very good. It is 90% accurate and I don't need to do anything. But that is wrong, right? Just because of that, your data is biased to non-diabetic person, right? So in such cases, you should handle that imbalanced via smart techniques, synthetic minority or sampling or undersampling technique. Next one is the training set versus testing set. Okay. So when you have, let's say, 1000 data sets, first you identify that you will take either cross validations or n-fold validations or two-fold validation. And based on that, you train your model. So what is cross validations or k-fold validation? So just consider that you have 1000 data points and you will divide these data points into 100 subsets. Okay. So first you will take uh, 80% of data. So you will take 8 sets for training and 2 sets for validation. Next, this is going to be rotated. Next one will be out of these 8 sets, 1 or 2 will go into the validations and the new sets will be coming for training. So this is called coupled cross validation. Why it is important? Just because when you do cross validations using coupled, all of your data is get seen by your training algorithm or machine learning algorithm, and your machine learning model will be quite more robust. It will have more understanding about your data. Now, as I was explaining in the imbalanced data sets, right? So sometimes people thinking that accuracy is very good, then I don't need to worry about anything. I'm very happy. But if 95% of patients do not have a disease and the model could achieve 95% accuracy, it is not a good. That doesn't mean it is a no disease, right? So in such cases, especially in these medical cases, precision and recall is very important. So what is precision? Precision measures the percentage of true positive predictions out of all the positive predictions. So it is only considering the positive, while the recall measures the percentage of actual positive cases were correctly predicted. Both matrices are crucial. So let's say in the actual, like let's say in 100 people has a positive about diabetes, okay, diabetic disease. So recall will check that out of this 100, how many actual positive cases that my model is identified. Let's say recall has identified 95%, right? So there is only 5% of the error. In that case, you should consider the recall. Okay, precisions and all you should consider where non-critical things are there, right? Let's say you are doing email marketing or promotions, right? In that cases, you should use the precision. But in such kind of cases where medicals, you should consider the recall. F1 is a harmonic mean of precision and recall. And AUC ROC score, it is again very important factors. So it is a receiver operating characteristics. Let's say you have three algorithm trained in a machine learning model on your data. Now you have to identify which model is doing best, right? So here this is AUC ROC pictorial representation. So you can see that this red color line is a random classifier. That means that you are just flipping the coin and you are saying that sometime it will be head and sometime it is a tail, right? So it doesn't mean that it is perfect, right? It is just 50-50% probability. Now over there is one yellow color line and you can see that it is just above it. It may be 60%. Then there is a green line, then there is a blue line. So you can see that whatever the line is trying to go this upside or to one side, this one. So the blue dots is a perfect, right? That means that it is properly identifying all the positive, all the negative bases. And below that, let's say this line is about 85%, right? So out of all the data sets, my model is understanding 85% variance of my data. Then this side, if you go in this negative side, this downside, the model is doing worse. Okay. So if you have a three machine learning model and you want to compare that whether my decision tree is working good, my random forest is working good, or my XGBoost is working good, in that case, you should use this AUC ROC score to the picture. So what it is considering, it is a false positive versus the true positive cases. Now, one important factors is underfitting and overfitting. Where overfitting that your model memory memorizing the training data, it is something like you can consider it student, right? So students in mathematics are trying to memorize all the syntax with data as well. Data, that means the input and formulas, right? If you tweak little bit in your mathematics question in your exam, right? That student will get failed just because he was memorizing everything. He was memorizing the factors, he was memorizing the formula, he was memorizing the numbers, right? Suppose he is memorizing that the outcome of this example number one is, let's say, 0.95. But you tweaking that, you are just tweaking one number by factors, right? The outcome will be the change. So this is the overfitting problem where your training data is memorizing by your machine learning model. Next one is the underfitting. Underfitting, that a model is too simple. It is not worrying or it is not capturing all the structures, right? Now, this is a pictorial representation. If you see, the first one is underfitting. That means there are two types of classes, but my model is just doing one simple line. It is not trying to understand anything. The next case is appropriate fitting, where it is a curve. So this is like nonlinear cases where it is trying to capture all the points. Now overfitting, where it is trying to capture very detailed manner, right? So what kind of problems my model will get or fitting, in that case, my model will be unstable. Okay, so this should not be the case. This shouldn't be the case. This should be the perfect ideal case. And one more like underfitting. So that person is like uh, is wearing oversized dress. The perfect is that person is wearing the perfect size dress, and underfitting, that means that person is wearing the short dress. A common challenge in the decision prediction, so data privacy. Data privacy is very sensitive since, like, if you know in the news that last month EU region has applied a higher penalty, especially in this data privacy, GenAI and AI kind of data analysis, where it is get breaches, then 10,000 pounds direct fine punishment will be applied to any companies. So when you are handling this kind of um, this kind of medical domains data, you should make sure that it is GDPR compliance, it is HIPAA compliance. So how we can do that kind of things, right? So there are some technique. One is anonymizations or federated learning. Federated learning, that means your data will stay in your device, but the model will shared between different machines or different devices. Then the different differential privacy, adding noise to your data sets, right? Suppose rather than keeping your all the data as it is, right? You are adding some kind of standard factor noise. Like let's say I'm adding 10% noise to all of my variables, right? So it will get anonymized automatically. Interpretability is again very important challenge where, as I explained, right? If someone or some of your patients or is comes to you and say that, hey, why your machine learning model is saying this person is a predict a diabetic, then you should have that value. You should have that explanation. So there are two libraries. One is shape and line. These are the good libraries that can explain you all the features, importance, plot, why that decision is made to positive or negative, all the probabilities, all the contributions you will get in detailed manner with the pictorial presentations as well using this shape and line. Common challenges, one is the class imbalance we already discussed, right? So to tackle that class imbalance, there are the resampling techniques or samplings or undersamplings, or you can do a smart technique that can generate a new data sets. Data quality inconsistent or incorrect medical records can drastically affect the model's performance. Okay, so your data quality should be the consistent and it should be in the good, perfect, and good, perfect, and accurate manner. Okay, otherwise your models will be garbage in and garbage out. Now, what are the applications and of this machine learning in this uh, medical domain? Heart disease predictions, right? So where you can have a different kind of data sets and you can try out on the different algorithms that we already discussed, and you can check whether a person has a heart or heart disease or not. Cancer diagnosis, right? So cancer diagnosis you can do via the CNN, where you have set up input image, then you do pre-processing, or if images are lower, then you can do data augmentations and you can identify that percentage cancers or not. Diabetes predictions again is a machine learning problem where most of the data are numerical features like age, BMI, glucose levels, and based on that you can able to identify diabetes types. Alzheimer disease, it is again the CNN problem where you have MRI and PET scan. You can pass to the different CNN layers using the deep learning techniques, and you can identify that whether the person has AD or not disease. COVID-19, we everyone knows about this, right? So there are different kind of things uh, that, especially the factors that input variables is SpO2, FPTT, body temperatures, right? Days of symptoms onset, right? So these are basically input features, and based on that, you train one SVM model. So SVM is a good model in such kind of cases, and where just because of there are lot many features, and based on the SVM, you can identify that whether that person is COVID or not. Here you can see that there is a non-severes and severes, right? So SVM will try to identify, create one simple pan in between these two classes, and it will give the output. Okay, so before coming to this, let me come back here, and I guess still we have around 45 minutes. Uh, I hope everyone has a Google account, and I'm sharing one zip file with you guys. So I hope you are excited for some hands-on. I don't know whether you have already good experience with this or not. So I'm sharing one link here. You guys can able to see the data and file here. Okay, let me paste it here. Okay, so whosoever would like to do hands-on along with me, they are good to go with this link. I guess you will have access. Someone please confirm whether you have access to link or not. Hello.
Yes, sir.
Okay, are you able to open the link?
Yes, sir. Yes, sir.
Okay, and someone has a question, Dr. Akhil Sheikh. So here, this drive I have shared, and you can open the disease prediction. Just open. Okay, let me make this link public so no one required to get a request. Okay, I just make this link public and again sharing it. Can someone try now? I hope you can now able to open this Google Colab. Are you able to open the Colab? Can someone please confirm?
Yes, sir.
Okay, thank you.
Yes, sir, it's processing.
Yes, sir.
Okay,
Yes, open,
great.
sir.
Okay, great. I have one folder that is folder is data, and inside the data folder there are two files, training and testing. Okay, so either you can copy in your Google Drive, or I don't know. Yeah, it will not allow directly, I guess, from my Collab account. So what you can do, like just create one folder in your Google Drive, data, and keep this file aside. This is predictions. You can also copy paste this file. Okay, like you can open this file and go to file and copy to collab. Yeah, save a copy to drive. You will have this option, so you can get this collab in your drive as well. Okay, so very first step is like I have to mount my Google Drive. So I'm just doing shift and enter. So I will get some resources from Collab, and it is saying that it is already mounted. I'm waiting for 2 3 minutes, just where confirmations from everyone. I am expecting confirmation from everyone whether they are able to comes to this point or not. Okay, you can download this data and again you can paste into your drive, and you have to open this Collab notebook. Let me know if anyone is facing issue. Are you able to copy data and open the Collab? Can someone please confirm? So shall we move ahead or shall we wait?
Sir, and I think understood. Go ahead.
Okay, okay, thank you. I have the data into my drive, and you can see that it's listing testing and training to CSV data. Now in this notebook, what we are doing, we are following all the steps that we were discussing, importing the data, then data cleaning, then we will apply k nearest neighbor, We'll check the model complexity, then we'll apply cross-validation, decision tree, random forest, support vector classifier, logistic, and matrices. So all the things that I explained on the session, we are going to do a practical on that. Okay. So very first is I'm loading this data. So pandas library, pandas.read CSV. I'm passing my base directory and training.csv, base directory and testing.csv. And you can see that my data is get loaded here. And I will showcase you there are 133 columns and around 5,000 records are there. Okay, so let's see first what are the informations and then okay, so before that I will just explain all the columns as well. Just a second. So in these from 30 to 60 there is indicate indices of the columns. Okay, so I'm checking that columns 30 to 60 columns. So indigestions, headache, yellowy skin, dark urine, nausea, loss of appetite. So these are the indices column 30 to 60 number, and we are going to check all of these are the encoded data and types of integers. So indigestions. So one column is indigestions. Okay, so before that, let me open all the columns as well. Okay, just a second. So these are the different columns. Itching, skin rash, nodal skin, eruptions, contagious. So it is a multi-disease classification problem. Severing, chilling, joint pain, stomach pain, acidity. You can see there are 133 columns. Now, from prognosis, I just want to check what are the different unique values are there. So fungal infection, allergy, GERD, chronic cholesterol, drug, and next one is where disease have a same number of target prognosis column, and I'm just checking that out of all these values, and it is saying that my data is not imbalanced. You can see that all the values. I did the real world scenario since this is a data sets, we can say that is a testing data sets, and here are pictorial representations of all the. So you just have to do. This is just pictorial representation of same, and all these values are showcasing one Okay, let me share my screen again. There was a network drop at my end. Next one is features. So let's visualize some of the frequency. So we are just checking the value counts. For 2000. and values between value count for each features. About different features. So let me explain. So these are the features. So what we are doing, we are iterating all the features follow. Just it take the feature indications. Then indicate total, and then again I'm saying that the so it will give you like it has a two values. Since this okay. Okay. Come down. So we were checking the redness of the eyes and counts and chest pain and and this is called correlation matrix. Okay, so sets we are taking all the records just 10 to 40. So we are just limiting the total 10 to 30 columns, and then we are saying that Japan.co correlations, and we are representing that into the heatmap segmentation. I'm just guys. So what it is indicating, okay? So muscle vesting. Muscle vesting, it is showing here one. So if you check here, the first muscle vesting, there is a is a perfect relations. And muscle wasting has a minus 0.12 correlation. So it is a significantly mutations. The column, third, fourth number of column, that is just 0.62 collinearity. That means by 1 point get increased by G6. This is a positive. The machine learning, mostly we are checking that is a 50% of the column, or we should work on that to remove the collinearity. Here you can see that muscle and another column has a 0.89 collinearity. Let me check the other column. The other column is repetition thought and testing has 0.89 collinearity. So it will help you to identify how these two features are together and why it's important to keep two features. Both are contributing the similar way, or model. That model will be unstable. Okay, so that is the reason we should remove the multicollinearity between data. Uh, the sort of weight 0. And I can see what uh, 5% is collinearity with weight gain. Colliness with each others. Here the example yellow skin coefficient, which means these features usually seen together. Cough and breathlessness also by our data. That means our data is perfect penetration. Now data cleaning. So we are removing extra not required just because it is a noise in our data. So we just remove that variable. Okay, it will already. Okay, anyways, let me go down. I already here. The next one is that we are training KNN. Okay, just want to make sure that how many number of neighbors we should consider. And so for that, there is an album method. Will help you to identify according to your need. Variable that is a prognosis, and we are dividing our data sets in train data. So this train data will be used for machine learning. This stage learn. And by running this, I can say that the optimal value of k is 1. Ideally, it shouldn't be this case just because it shouldn't be optimal. Or so by not considering this one, I'm applying so that I have three neighbors for identifying and or for predicting. And that I'm saying that k is predicting that. And I'm getting the accuracies from that means my model is working 100% perfect. And this shouldn't be the real world just because this is is the complex but the tuning. But I want to try a bit. So there's like checking the value from 1 to 25. So what I to 25, so check the accuracy. Okay, so every time it will say that it is 100% accuracy. So here you can say that when I am to every time it is a random data, and that's why this is the case. So the right in the reality it is not the case. Now cross careful cross. Okay, and this is cross. You know, I'm passing the train and I'm passing the test, and I'm saying that k-fold is equal to 5. So that means that what are the number of variables I have no records right now? I have around 5. Rest is a validation. So this is how k-fold will work. So 1 1 1 1. So this is showing 5 times 1. This okay, and totally garbage data, and that's why it is saying that some randomness. If you just add some randomness into these data sets, and tree classifier percentage. Okay, this is not that much of perfect type. So if you want to replicate the same uh, same random set, so decision tree classifier we discussed that decision tree and decision trees working on this entropy and log loss algorithm, and default is Gini entropy, and based on that it will train the machine learning. This is one algorithm. Trees get built, and each tree will try to create a different set of trees. The tree will different set of features. Uh, algorithm. Here you can see that the kernel RBF algorithm, and this algorithm is giving accuracy is 1. This is giving me 1 just because it is a total random data generated data. Like if you want to check or if you want to make real some changes with the different results. Now what happened? In predictions. So one is KNN, then SVC, decision. We just want to make one summary and we want to identify. Matrix is if it is a binary, then it is a 2 by 2 nodes, positive, negative, actual versus positive, negative prediction. Then in that case, it will be 2 by 2 boxes. What we are comparing, first we are taking a predictions of all the Y predictor. SVC, again, it is saying that everything is firm. And all these features are one. And next one is the random forest classifier. It will look perfect, and you can also interpret the results. This is the end-to-end demo, and I hope everyone is able to load this data. Everyone is able to question.
Any questions, participant? No, sir. Go ahead.
Okay, so that is the end of presentations, and I explained about like how we can do hands-on on algorithm and forest SVC the algorithms and how you can do feature selections. So I explained all these different techniques. You can project or whatever the analysis you want to do. You can just the results as well. So that's all from mine. Thank you. Let me know if any questions right now or even in the future. You can reach out to me on my LinkedIn
Any questions, participants? Uh, no questions, sir.
Okay, thank you all for having me, and
Uh, Thank you, sir. Thank you very much, sir, for this hands-on session and explaining this about this AI. And thank you very much for this wonderful session. Thank you, sir. Participants, there is a 5-10 minutes break, and then after the next session will start.